Now we're going to summarize what you need to know about the graphs of the sine and cosine functions. This information in this video is just absolutely essential, and you gotta memorize it. So what we gotta be able to do is we need to be able to generate these graphs fairly quickly that we drew in detail in earlier videos. We're never gonna plot so many points. In fact, to draw the graphs quickly, all we're going to rely on are the quadrantal angles normally. So 0, pi over 2, pi, 3 pi over 2, 2 pi, so on and so forth. Those quadrantal angles are the key to graphing because they give us the 0, the high points at 1, the 0, the low points at -1. So on and so forth. So let's go ahead and talk about drawing these graphs. So we're going to graph first. I'm going to also write y equals sine x now. We're going to call the input x. We're going to call the output y. So what we're calling x here is theta on the unit circle. But we're going to kind of leave that behind. In fact, eventually we're going to find out x doesn't even have to be an angle. And so I'm going to set up axes. And using graph paper is nice. And now on my vertical axis, all I need to label is 1 and -1. That's on the y-axis. On the horizontal axis, or x-axis, I'm going to label the quadrantal angles. So you just want to be consistent in your scale. The x and y scales don't have to match, but to be consistent here, so like if I go pi over 2, that's like 90 degrees, then pi, then 3 pi over 2, and go a little further here. This is 2 pi. And if I went in a negative direction, I want to label that here also. It would be negative pi over 2, negative pi, negative 3 pi over 2, and I want to go far enough so that we have negative 2 pi. Now I'm relying on the quadrantal angles from the unit circle. I know sine of 0 is 0. At pi over 2, or 90 degrees, the y-coordinate on the unit circle is 1. So sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2. So the y-coordinate 3 pi over 2 on the unit circle is -1. Sine of 2 pi is 0. So 0, 1, 0, -1, 2 pi. That's enough for me to be able to draw the wave pattern. And we got to be aware that this pattern continues on and on forever in both directions. At negative pi over 2, I get -1, negative pi 0. At pi over 2, 1. At negative 2 pi 0 again. And that continues in the negative direction. So you need to be able to generate this graph by hand from memory. Other facts about sine that you need to know is you need to know the domain. We're going to say all real numbers. We're just going to, even though we think of the input as an angle, we're going to think, all possible x values correspond to points on the graph. It extends infinitely in each direction. The range, though, of the sine function, we never have output values or y values on this graph greater than 1 or less than -1. So we always fall within that closed interval from -1 to 1. So there's something we call the period of sine, and the period is one cycle. Or if you start at 0, the period is how far you go before the graph starts to repeat itself again. And on this graph, you can see that period from 0 to 2 pi. So we say the period is equal to 2 pi. Sine is an odd function. In symbols, that's can be expressed by saying sine of minus x is always minus sine of x. There's also something called origin symmetry that we'll talk about more. And sine is not a one-to-one function, which is something we're going to be concerned about later in the course. So there's our sine function. Now let's do a graph of cosine. So you also have to be able to generate the cosine graph from memory. Notice that what we're calling x here is, just like with sine, theta on the unit circle. And what's weird about the graph right now, we'll get used to it, is the y-coordinates here were x-coordinates on the unit circle. And so let's go ahead and set up our axes again. I'll use the same scale as I did with the sine graph. Again, the sine and cosine graphs are very similar, but kind of different, right? So I need to label 1 and -1 on the y-axis. And on the x, I need to label my quadrantal values. So 0, pi over 2, pi, 3 pi over 2, 2 pi, and in a negative direction, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And now I'm going to rely on these quadrantal angle values of cosine to help me draw the graph. Cosine of 0 radians or degrees is 1. In fact, like something that's always helped me out is just always remembering sine of 0 is 0. The sine graph passes through the 0, 0 point. The cosine graph passes through 0, 1. Cosine of pi over 2 is 0. Cosine of pi is -1. Again, the x-coordinate on the unit circle is -1. That becomes a y-coordinate here, and I think I went down too far. And the cosine of 3 pi over 2 is 0. The cosine of 2 pi is 1. I go 1, 0, -1, 0, 1, and that pattern continues. In the negative direction, cosine of negative pi over 2 is 0. Cosine of negative pi is -1. Just continue the pattern. 0, and then 1 at -2 pi. And pattern continues in the negative direction. So there's the graph of sine and cosine compared. But you need to be able to draw them both with this amount of details. Notice how it depends on the quadrantal angle values. 0, pi over 2 pi, 3 pi over 2, 2 pi. Additional information about cosine. The domain same as sine, is all real numbers, or interval from negative infinity to infinity. Range is the same. Y values always fall between -1 and 1, sometimes -1, sometimes 1. The period is the same as 2 pi. We often think of a period of cosine as starting from 0. And again, the idea is, when does the graph start to repeat itself? It starts to repeat itself after we've gone one full time around the unit circle, is what it would correspond to when we've gone 2 pi radians. Now, here's how sine and cosine are different. Cosine is something called an even function. The even function property is that cosine of minus x equals cosine x. And on the graph, that's illustrated by the fact that the graph is symmetric around the y-axis. The two halves of the graph actually fold together if you fold along the y-axis. That is not true for sine. And cosine is also not one-to-one. So I'm just going to pull the camera out to try to get all this in one shot, because this is what you need to know about the sine function and what you need to know about the cosine function. Again, this has to be memorized. You got to be able to generate this pretty quickly. Like this, you just got to know inside and out all the information on this sheet.